Bringing together geographic and laboratory researchers, field trips and fiction, I am going to tell you, through my perspective as a human, as a visual artist, about a project, an art and science project, about an investigation around the disappearance of an island. This project is called Lost in Fathoms. It is the fruit of a collaboration between the researcher and creative mind Jean-Marc Chomaz and myself. We developed this art and science research over 18 months in his hydrodynamics lab, the LADIX, in École Polytechnique, where I am artist in residency. How did we proceed? To describe our journey, I need to tell you a story. The story of an island, which arises from our imagination. This island is called Nuuk. Nuuk comes from the Inuit etymology. It means the summit, the headland. It thus became for us a promontory, a vantage point from which to explore, in the light of fiction, this new geologic age called the Anthropocene. The Anthropocene means the age of mankind, an age where human activities have a geologic impact, which, like a period of intense volcanic eruptions, transform the planet. Thus, this island, Nuuk Island, became a promontory for us to explore this new geologic age, to put into perspective human time to the time scales of the ocean, of the lithosphere, that of the geologic sphere. This promontory also allowed us to shed light on this entangled relationship between all elements of the planet. As a matter of example, to speak about this entanglement, we can go back to the book of Bill McGuire, the geologist, this book called Waking the Giants. In there, he describes how the rising of sea level increases the pressure on the continental plate, and by this triggers more frequent earthquakes. But before going any further, I would like to introduce you to the story of Nook.
L'île de Nuuk se trouvait au centre d'importantes turbulences océaniques. Des tourbillons générés par le passage de courants d'eau, denses et froids, qui plongeaient vers les profondeurs. Bien que recouvert d'une épaisse couche de glace, Nuuk était une île volcanique, créée par la poussée depuis le manteau terrestre de roches anormalement chaudes. Cette poussée avait engendré la déformation du relief sous-marin alentour et l'apparition d'une chaîne de montagnes, en grande partie immergées. Ces montagnes avaient jailli à la jonction de deux plaques tectoniques, constituant une faille qui traversait l'île, la fracturant d'est en ouest avant de s'évanouir dans les profondeurs de l'océan. Lorsqu'une troisième expédition atteint les côtes de Nuuk le 30 juillet 1976, les scientifiques embarqués remarquent que la partie de terre émergée avait rétréci et que la ligne de côte sud avait reculé de 953 mètres. Il fut décidé d'installer un poste d'observation relié au continent par satellite. Cependant, en 2012, la station cessa d'émettre. Des images satellites révélèrent que l'île avait entièrement disparu de la surface de l'océan.
C'est à cette même période qu'à Brisbane, en Australie, le 34e Congrès international de géologie se penchait sur la question de reconnaître ou non l'Anthropocène. Une ère géologique nouvelle dans laquelle nous serions entrés. Une ère où nos sociétés industrielles deviennent un facteur majeur de la transformation de la planète. L'activité humaine impacte la Terre et son écosystème à tel point qu'une nouvelle strate géologique est en train d'apparaître. La disparition de l'île de Nuuk est un événement singulier ou la conséquence directe de l'émergence de l'Anthropocène.
Indeed, this question formed the center of our art and science research for more than a year. This research also involved historians and philosophers, oceanographers, geologists and physicists. This investigation started by an expedition in a landscape with similar geologic characteristics than on Nook Island. I went to Iceland because this place is also located at the junction between two tectonic plates. On one side, the North American plate, on the other side, the Eurasian plate. There, I walked in the frontier between these wandering plates in search of clues, of evidences about possible geologic events that could have occurred on Nook Island. In some parts, the fracture was so narrow that you could touch both continents with both hands. In some other parts, it was filled with water coming from the last ice age. I dived into this part of the fracture and extracted this block of basalt, this sample from the wandering continents. Then, back in Paris, with Jean-Marc Chomaz, we took this sample of basalt to the lab of Jérôme Fortin in École Normale Supérieure in Paris, and we placed it in a press like this. This press allows to recreate similar conditions than along tectonic fractures deep under the surface of the Earth, under similar constraints of pressure and temperature. Or block of basalt fractured, and the fracture released a sound. This sound. What is it telling us? It gave us access to a geologic history, an history that we then studied at the scale of the lab. We recreated a formation, the formation of the first fracture in a continent some 358 million years ago. Then we looked at the impact of the motion of a tectonic plate onto what is known as an earthquake, which at its turn can also trigger geologic events, maybe more punctual, like a landslide. However, in the light of these experiments, nobody could ascertain that a sole and unique force was behind the disappearance of Nook Island. To slide, an island may need to be eroded by waves, storms, high precipitations. It is a question of interaction between the geology, the ocean, the atmosphere, the biosphere, the cryosphere, which has to do with ice, and what could be called the anthroposphere. We then decided to conduct the second part of our investigation around another natural force, around the oceanic forces. As we saw earlier in the film, the island of Nook was surrounded by turbulences. There were the surface signature of water diving into the abysses to start a journey along a circulation called the global oceanic circulation. If you were to follow one drop of water from this circulation, it would take you 1,500 years, that is to mean 60 generations, to go back to its initial point. In our research, we captured a wave. This wave is kept in motion. It is in a tank composed of different densities, and it is made visible via a small source of light which is placed behind the tank and casts the shadows of the wave. What you are seeing here is the physical projection of this wave. More symbolically, it is the scale down of this part of the ocean, the North Atlantic, where the water is so cold and dense that it can dive and start its journey along the global oceanic circulation. We then made a call to the oceanographic community to help us find some water that may have been on the journey of this wave. Thanks to 21 oceanographers, we could collect 33 real samples of water. These samples were captured, as they say, along this global oceanic circulation at different depths of the ocean. Some were taken at the surface, some much deeper, much deeper, up to 9,000 meters deep. These samples are memories of expeditions. They are also keys to understand the evolution of deep oceanic currents and their impact on exchanges with the atmosphere or the biosphere. These samples are imprints of past climates, but they're also the prediction of its future evolution. This collection of water let us assume that our wave had indeed belonged to this global oceanic circulation. Our wave had started its journey along the shores of Nook Island, a little bit more than 1,500 years ago. There it dived along the shores of Nook Island and 2,000 meters deeper started its journey through the abysses of the Atlantic. It crossed the Atlantic from north to south to reach the Antarctica. There, after several centuries, it eventually managed to escape its circumpolar current and rose at the surface of the ocean to reach the Pacific. For a reason still unexplained by scientists, it drove backwards, fighting against the Cape of Good Hope, rising in the Gulf of Mexico, cooling down in the meanders of the Gulf Stream to get ready to dive once again along the shores of Nook Island. However, in the meantime, Nook Island had disappeared. We have seen that this global oceanic circulation, this massive loop of water, plays a key role in the regulation of the planet's temperature. But with recent changes, with, for example, the melting of the Arctic, which is bringing a massive volume of fresh water into this part of the ocean, the Atlantic, where the water needs to be dense and cold to dive. The fresh water is changing the characteristic of this water, which may not be able to dive anymore. Then studies are showing that this circulation may be slowing down, if not stopping. How we are seeing in this presentation, the relationship between all elements of the planet, including Earth, is very sensitive. Then I would like to ask you a question. Could the disappearance of Nook have had an impact on the characteristics of this global oceanic circulation? Could it even be at play in the changes, in the destabilization of the planet's climatic balance? By now, it must have dawned to your attention that the ground which forms Lost in Fathoms is in fact a fiction. Nook Island never existed. It is a creation. That is not to say a lie. This fiction is based on real facts. Indeed, real islands on the planet are disappearing. We can think, for example, of the Maldives. But you may ask, why fiction? Our use of fiction here could be put in parallel to the use of thought experiments in science. What is a thought experiment? It is about imagining situations that, in practice, are unreachable, but which allow to create shift of paradigms, to open new gate of research. We could even say that it is a thought experiment which is at the origin of modern science in 17th century with Galileo. In one of his experiments, Galileo starts one of his experiments by, if we take two bodies whose natural speed are different, and then he proves that all bodies fall at the same rate, whatever their mass. But did you notice here the use of the if, this what if, this form of fiction which is sometimes sufficient to change the context for us, to shift our mode of thinking, to engage with the world through a new lens, to maybe take the point of view of an ocean, to let a mountain speak, to engage with the timescale of the ocean and of the lithosphere, with the timescales of the planet, which spans over generations and generations. But first and foremost, Lost in Fathoms was created as a self-reflexive form of thinking about our relationship with our planet. Fiction is used here as a critical tool to engage with reality from a different perspective. And also, it is about creating a distance from which to shed light on this new geologic age and its implications. Thank you.